So Bernoulli's principle, it is why the great planes of this world can fly, or something as simple as your shower curtain moving in towards you when you turn the water on. So what is the principle behind Bernoulli's principle? Well, when the pressure of a fluid in a pipe increases, or a fluid or any fluid moving flow increases, its velocity will decrease, or if its velocity increases, its pressure will decrease. So why does this happen? This is due to conservation of energy in that fluid. So, given by this equation, the difference in the pressures will be equal to the difference in the kinetic energy and the potential energy, where this rho here is the density of the fluid. And this could be rearranged such that one of these pressures plus each of its plus the kinetic energy and the potential energy will be a constant. And this is the energy of a section of pipe. For example, this section of pipe with differing widths. This is called a Venturi tube. So the energy in this section of pipe will be equal to the energy in this section of pipe. The pressure here will be greater than the pressure here, but the velocity here will be smaller than the pressure here. Than the velocity here. Also, the volume of the fluid must be the same as the volume of the fluid going here, which is the perfect segue into how this works. So say 10 million liters of water flow through this side, and 1 million liters of water can flow through this side. If the pipe's velocity is the same, then where are you losing? You're losing 9 million liters of water to nowhere. So to explain why this is, the fluid here is moving 10 times faster than the fluid here to accommodate for the change in the size of the pipe. The actual acceleration of the fluid, however, is due to the fact that the pressure here is higher than the pressure here. Because this pressure is higher and this pressure is lower, as many of you know, things will flow from high to low. This causes a force on the system this way, and the fluids here will accelerate into this pipe and go faster. And when the pipe gets bigger again, the pressure will be lower here and the pressure will be higher here, and this will cause a net force, a force going back towards the pipe, slowing down the fluids going past it. So the velocity here will be low, higher, and lower, assuming these two are the same cross-sectional of the same. Flight and wings. So say this is the cross-section of a wing. Alright, so you have the leading edge here and an end here. So as air flows into it, some air will go here, and some air will go up over the wing and down. So the air on the top of the wing will be traveling faster than the air on the bottom of the wing. And if the velocity here is higher than the velocity here, given by Bernoulli's principle, the pressure here will be much lower than the pressure here. And because this pressure is lower here and higher here, things will want to flow from high to low, and that will cause a net force pushing up on the wing. And because of this force, the wing will move up. This is called lift. And planes fly due to lift. Lift, if the force of the lift is greater than the mass of the plane will be able to fly. This combined along with thrust and drag and the weight of the plane will give you the four forces of flight. Drag is just aerodynamic resistance, mass is the mass of the plane, which will bring you down towards gravity, and thrust is what's pushing you forward, say your jet turbine or your propeller. So basically, this is a combination of Newton's third law, which, because the force is pushing up on the wing will push down on the direct the air down to the ground and go up, and Bernoulli's principle, which causes the force on the wing. Another example of Bernoulli's principle is in cars. Carburetors use Bernoulli's principle to mix fuel and air so that the fuel will explode in the engine and drive the car forward. Now, back when they used them, this is how they worked. Well, there's some parts missing from here, but they're not really important to understand how Bernoulli's principle works in a carburetor. So, air comes in through the top here, and fuel is stored here. The air will go in a wide section pipe and then into the aptly named venturi, a small section of the pipe, and then will expand out again. This area's pressure will be lower than out here and over here, and the fuel will move from this area of high pressure to the area of low pressure into the air. The fuel in the air will mix, and this goes to the engine to be burned. There is Bernoulli's principle, how it works, why it works, and some applications to go with it. Thank you for watching.